Let's go and see what this question is all about. Right. So we are told here that we are given a combined constant and arithmetic sequence with the following terms. It's 5, 4, 5, 7, 5, 10, and so on and so on. So clearly you can see something very important about what is going on here. It's a combination of two patterns. It's going to be 5s plus a particular pattern which happens to also be an arithmetic pattern. So these terms are joined together to make up a long list of terms. So when you're dealing with things like this, you've got to be extra careful about how you approach the positions of the terms and how you approach your formulae for the general term and those kinds of things. So let's look at what the question is in this case. We are told here that we need to determine the position of the term 1051. That's like 1051 in the combined sequence. Right. Now, what does this look like graphically? Well, it looks like this. There's 5 clearly, there's 4, there's 5, there's 7, there's 5, there's 10. There's going to be a lot of terms. Somewhere there's going to be 5, and then there's going to be 1051, and then there's going to be another 5 again and another term after that. So what we are interested in is in figuring out where is this guy, at what position of the combined sequence, not only as a member of the arithmetic guys, but if you look at the whole combined sequence, where will that term be? Now, the most important thing all the time when you're dealing with a combined pattern is to separate them, right? Treat them separately, put the first one side, and then put the other sequence on the other side, and then treat them separately. Then you will consider recombining later on once you have finished working out whatever you could be interested in. Right, so now let's separate them and see what is going on. So we've got a gang of the 5s. There's 5, 5, 5, 5, 5 all the way, and then we've got these guys that are as follows. There's 4 with this guy who is 7, and then there's another guy who's 10 there. So I'm going to take those guys and put them side by side next to each other, and we're going to zoom in more on them, right? So 5, 7 as well as 10, and then later on we're apparently going to have 1051. So we want to know, where is this guy going to be? All right, now I'm going to continue here and say, okay, if we have a sequence like the one we're currently looking at now, right, where will this term be? At what position of these guys, this particular 1051? So the general term is given to us by a plus n minus 1 multiplied by the common difference. We know for a fact that we are looking for the position for 1051. The first term is 4. We know the position is unknown. We are looking for that. The common difference, which is the difference between subsequent term, is always the second term minus the first term, which in this case happens to be exactly equal to 3. Very important for us to keep that in mind. Right. Now, if we continue here, we're going to get something very exciting, because we are going to put 3 in brackets here, and then we can simplify and solve for the value of n. So if you continue, you get 1051 is 4 plus 3n minus 3, then you get 1051 is 3n plus 1. If you subtract 1 on both sides, that's correct mathematics. You guys call it transposition. We're not really transposing 1 to the left. We're just adding, or in this case, subtracting 1 on both sides to make that 1 to be 0. These things are known as additive inverses. This year, we're very serious about correct terminology in mathematics. We don't want you guys to just mention things that you're not aware of. So 1051 minus 1 is going to give us 1050. So we're going to try and divide both sides by 3. So I'm going to divide by 3 here. I'm also going to divide by 3 on this other side. So then we're going to have n is 3 and then 50. So now 1051 is the 350th, right, term of the arithmetic, guys. This is for the arithmetic pattern when we're looking at that particular pattern on its own. Very important for us to keep that in mind. Not for the combined pattern. It's just for the arithmetic pattern. Now, where is it in the whole pattern that is combining the 5s as well as these guys of the arithmetic? So let's go up and check what is going on. I want you to pay attention to something very important here. Let's look, for example, at the number 10. I want us to look at the number 10. Now, if you look at this, you will notice that 10, this 10 that you're looking at here, is on the whole list, right? If I look at the arithmetics alone, the first arithmetic is 4, the second is 7, the third is 10. So this term is the third of the arithmetic, guys. It's third of the arithmetic pattern, right? But in the combined pattern, it is number 1, 2, 3, 4, 5, 6. So it is the 6th of the combined pattern, right? So you have to keep that in mind. It is the third, 10 is the third term of the arithmetic, but if I add the other 3 5s, then you are suddenly looking at 6 terms in total. So that makes 10 to be the 6th. Now that means you need to double if you are looking at the whole pattern. So the same thing is going to apply with our question that we are currently looking at now. If this 1051 is at position 350, it means 1051 is 350th of the arithmetic progression terms. Therefore, it is at 350 times 2, right, which is exactly 700. It's the 700th of the combined pattern, right? Please keep that in mind. Very important for you to consider that this is a combination of two types of patterns. So if you are combining things, your position is going to be always double of what you are when you're just sitting with your own members.